Okay, I should be streaming right now. Um, yeah, now I have feedback from the YouTube thing that the connection is excellent. My name is Victor. I'm in my last semester of computer science, and before doing bachelor's work, I need to do a course in writing an independent research essay, so like kind of like a literature review. This is why I'm reading like a bunch of articles about a specific topic. I'm not really going to share the question that I've chosen, but I will tell you about the area, like what it's about. So it's basically the goal is to decide or like kind of like think about um, what is the what should be considered when designing kind of like a database architecture or kind of like a infrastructure. It's a little bit in that area, and I have read, and this is for like specific like industry or kind of like web application, and we already know like from the research that I read, I already know that I'm gonna talk about UDFs. I'm gonna talk about these other software like Hadoop and Spark, like from Apache, and then I'm also gonna just consider like C++ native systems. You know, like they already have um, like functionalities in there, but everything comes with a cost, right? You're kind of trading efficiency versus speed, and sometimes you want to have the best of both worlds, but this really depends on the context. This is why, so like I need to figure this out. Like, what do I have to think about? Um, I'm still a little sick. I thought I was better. Sorry. Okay. So I was thinking about reading a paper before I start my job. Currently, it's like 9:47. I start work usually around 11, because my colleague comes in at work at 11, and we can yeah, work together. But here I have this article. It's open access, so I think I'm allowed to share it. Like the whole article is basically online here for free. You can just Google it. I'm gonna read Engineering Sustainable Data Architectures for Modern Financial Institutions. I don't know where there's a cross there. I hope nobody. I hope this is not what I think it is. Um, this is written by Sergio Ionescu. Um, let's just Google him real quick. Who is this guy? Right. Um, come on. Didn't I copy? Okay. He is. Who is this guy? Let's see. Department of Economics, Informatics, ResearchGate. Cool. Let's also look at the institution, Department of Economics and Cybernetics, and Bucharest University. Okay, this is Romania. Okay, and he's the first author, so I'm gonna call this wait, let's see, do I have my Excel list over here? Like I have him here. UNESCO et al. 2025. Okay. And the AI has already kind of like um you know, I've already extracted some information using a copilot, but the thing is, can't really trust that 100%. And this is one of the pitfalls from using AI to study your work, is that, you know, it's actually double the amount of work, because you want to use the content that it produced, but then you have to make sure that it said the right thing. So you still have to actually read the article, understand it, think about it, and then the extra steps using the AI is seeing, okay, how did it figure this out? Is it really correct? Can I write it in my own words? So then, I mean, I don't know. Every time I try to implement AI into my workflow, and then sometimes it's good, sometimes it's not so good. This course, I'm still a little unsure how good this was to choose this. Either way, I'm also using this for this course reference manager, because I have this Apple computer, and my university let me have an account with Mendeley. Personally, I would like to build my own reference managing system, but I mean, I have this now. I can save some time. Let's just, I already have all my papers in there. Let's see if I wrote his name correctly. No, Ionesco. Oh, with an O. There we go. So, my goal for this hour of studying is to just get an idea of this article. It's very long, 45 pages. I'm definitely not going to be able to read all 45 pages of this. If it's, let's see how many of those pages are references. So 40 pages. Okay. Yeah. Let's just get straight into reading, and first we need to decide the core thesis in my own words. Okay. So we start by reading the abstract. Oh, I think I have some kind of streaming health issue going on. YouTube is not receiving enough video to maintain smooth streaming. The viewers will experience buffering. Okay. How do I fix this? I'm not really sure how to fix this, so there are no viewers. It's fine. I'm just kind of doing this for myself anyway, to motivate myself to study, because I know I'm not a researcher. I'm not gonna work in academia, but I still need to do this course. And the thing that I do have is a really good grit. Like I developed the skill to like kind of like grit through things that I honestly find a little bit boring. You know, this is interesting. Like I don't know how to engineer a sustainable data architecture for modern financial institutions. This does sound pretty cool, but like the actual reading and looking into the concepts, understanding, you know, what's going on, it's not necessarily my cup of tea, but I still do it. It's a valuable skill to practice. I also have some experience already from doing a master's in teaching. like, so I know how to read, right? But this is a subject that is more technical, and it's not. Yeah. Okay. So we just keep reading now. So modern financial institutions now manage increasingly advanced data-related activities and place a growing emphasis on environmental energy impacts. In financial modeling, relational databases, big data systems, and cloud are integrated. Still some background here. Taking into consideration resource optimization, sustainable computing. Okay, we suggest a 4-layer architecture to address processing issues. I see. So some kind of architecture for some issues that they're having. I guess the issues being non-sustainable computing and not optimized. So the layers of our design are for data sources, data integration, processing, and storage. Data ingestion processes, market feeds, transaction records, and customer data. Real-time data are captured by Kafka and transformed by extract, transform, load. Apache Kafka keeps coming up in the articles that I'm reading. It's very interesting. And this extract, transform, load a pipeline, I'm not sure how old this is. I read in a different paper that some people they managed to kind of like make a hybrid thing. Or maybe this is the paper, maybe. Okay. The process layer is composed of Apache Spark for real-time data analysis. Right, yeah, this is I've already read some of this paper. Okay, so, and Hadoop for batch processing. So this is actually, I Googled this already. Apache Spark is really good for streaming data, and Hadoop is more like for batch processing. So Hadoop focuses on like copying the columns of data table, let's say, and Apache Spark focuses on each row. Yeah, let's just to make sure, just to check my sanity here. What was Kafka again? I think Kafka was some kind of like a node thing where it helps you, let's see. It's an open source distributed event streaming platform used for high performance real-time data pipelines and streaming analytics. It's scalable, fault tolerant message broker, handles trillions of messages daily. So the fact that it's fault tolerant gives it plus points for being a reliable tool. High throughput, low latency. Data is organized into topics. The main APIs are these. Event-driven architectures. Okay. I'm just gonna copy this, put it as a comment for Kafka here, and now we go to Spark, Apache Spark, and it is an analytics engine for large-scale data processing. Let's just see what the what it is. It utilizes in-memory caching and optimized query execution for fast analytic queries against data of any size. Yeah. Amazon Web Services, very reliable source, but I'm not gonna use that source for my my essay. I'm just making notes here. And Hadoop was also open source, used for distributed storage processing of massive data sets across clusters of commodity hardware. It provides high fault tolerance, allowing it to automatically handle failures, parallel data analysis. Okay. Oh, my computer is really hot. Maybe I should stream from my Mac Studio instead of the Mac Air. This MacBook is from 2021, I think, and yeah, it's like an M1 chip. I bought it from a refurbed store at like 500 euro. It's honestly it's a great value because it doesn't have any ventilation system. Also means that doing this kind of stuff is gonna take a big load on it, and I guess it's not designed for streaming. See, okay. Okay, time goes on. Let's see. Okay, and a machine learning infrastructure that supports predictive modeling. In order to optimize access patterns, the storage layer includes various data layer components. The test results indicate that processing of market data in real time, compliance reporting, risk evaluation, and customer analysis can be conducted in fulfillment of environmental sustainability goals. What goals are these? Like, I'm not actually interested in environmental sustainability for this particular paper. So, but they talk about Kafka, Spark, Hadoop. This is what I'm gonna take from this. It's gonna be like reliability, the theme of reliability, because this is one of the topics that I kind of saw. This is what I would consider when I'm gonna write my essay about what to consider for building database architecture and infrastructure. Okay. Yeah, the metrics from test deployment support the implementation strategies and technical specification of architecture components. We also looked at integration models and data flow improvement with applications in finance. This study aims to enhance enterprise data architecture in financial context. Enhanced enterprise data architecture in the financial context includes guidance on modernizing data infrastructure. So, in my opinion, this is a very relevant paper for me. Hold on just a sec. I got my phone here. Okay. This is just gonna check if I got any work emails. Sorry. Okay, it's not relevant for me. So just from reading the abstract, I can tell that the thesis for them is going to be, come on, what's going on here? That they designed an architecture, that utilizes very resilient open source programs, Hadoop, Spark, Kafka, to process data sustainably and still fulfilling requirements for whatever this data is going to do. This is what I think is going to be the main thesis. Now I'm just really curious what the AI thought. So we are UNESCO, and Primary systems. Okay, core thesis. Let's check it out. A unified four-layer reference architecture can reconcile performance, compliance, and cost sustainability by orchestrating relational database management system, big data frameworks, cloud services with data classification, event filtering, versioning, encryption, zero trust, and hybrid residency. Okay, this is all new information. They did not say this in the abstract, but maybe they talk about this in their thesis, like along in the introduction. Okay, advancements. Usually in an introduction, it's like a funnel, they start talking about general stuff, and then they dig into like they start focusing more later on. Here they're still describing. Here they're gonna talk about like the weaknesses of like what's going on here, and then they talk about one solution for the problem, and then like another however, and you know what, it's not so straightforward to apply this other solution. So in response, okay, in addition to balancing performance, scalability, and compliance requirements, systems struggle to achieve in isolations. These players offer a wide range of financial services. Okay, despite the advancements, there's evidence another shortfall. GDPR. This is where the AI started getting this for EU clients. And I guess it makes sense because the universities in Romania, they have to follow GDPR. And here they talk about... No, wait. Now they start focusing in on their solution, I think, because now they start... Like, although there is a substantial literature on each of these three pillars, relational databases, big data frameworks, and cloud platform, as well as research that addresses the combination of these pillars. So it's this research for the combination. Another issue. Several banks have several separate systems. Yes, big problem. I mean, this is actually still good that they problematized, they really find their niche here. And of course, at the end of the day, it's about the cost, the bottom line. And these are financial systems, so they really care about the bottom line, right? You see, the thing is, I still don't see... there we go. Like, studies have shown, blah, blah, blah. But here, to address this research gap, this research considers... So now they're talking about their solution. In doing so... So they're considering all these requirements and architectures and stuff. And they also have to compare performance metrics. I think my dog is doing dog stuff. Okay. Let's see, get back on track here. There we go. by proposing this multi-layered architecture, this study offers a new direction for modernizing legacy systems without compromising governance standards. Okay. So they are so this is a or maybe I can just put it here. Multi-layered. I'm gonna put this as green here. Putting this result, this extent research expands the scope of depth. Showing how technology such as real-time streaming, Kafka, distributed processing, can be orchestrated with standard relational system multi-layered hybrid architecture. Yes. And they even have their research questions, which are 3. Let's see if I like all 3 or if I should just focus on one. So, what are the main trends, challenges, and strategies by integrating relational databases, big data, cloud computing, and financial institutions based on a systematic review of the recent literature? So this can be good to read, but not necessarily something that I would use for myself, for my research essay. Because, I mean, I'm doing a literature review myself, so, I mean, it's always good to read other people's literature review so that I can get better at writing literature reviews. But, okay, how can financial institutions implement a hybrid cloud architecture that optimizes operational efficiency while ensuring compliance with... Yeah, so I like half of this question. This is really nice. I don't really care about the law. For my research essay, it's not so relevant. And then here, how do these technologies impact financial data management and analysis in terms of scalability, processing speed, and efficiency? Effectiveness, not efficiency. Cost effectiveness. I'm not really sure how can you be cost effective? Okay. Okay, I've been streaming for half an hour. I have a feeling that my screen has been frozen. Luckily, I don't have any viewers still, I think. And I'm just gonna stop here and study by myself instead. Maybe I'm gonna, next time I stream, I'll do it from the powerful computer, not from my laptop. So thank you if you're watching this in the future. For I guess I hope I didn't bore you too much. This is my first stream. It's not gonna be like professional, obviously. So have a nice day, and yeah, see you.